Good morning. Today we are going to discuss about TMS320C6000 DSP architecture. So let's see, this kind of digital signal processors are being well known for three major operations. One is control optimized, power efficient, and high performance. Control optimized in the sense it can able to adapt it to any kind of a lower version of the signal processes. So whatever we are going to do the program or the architecture details which are available with the 6000 are able to made compatible with the 24, 28 versions of DSP processors, or they are all ready to suit or ready to map with the higher versions. And thus kind of a control atmosphere has been optimization has been taking place. The advanced features are being incorporated with the basic level of the codings, and it is power efficient in one another form because it will not consume more amount of the power. Though there are many units are there in order to perform the programming and the control logic, in order to provide the kind of the interrupts which are being going to come in to service this particular thing, and at the same time the memory blocks which are being associated with things, and there are so many other controlling applications are being kept here in order to perform a particular task will not take any amount of additional power requirement for in the case of TMS 320 version of a digital signal processors. Of course, this is go for real-time applications. Nowadays, the signals are not being taken as a recorded form. It will be taken as a stream, live stream. So, immediate responding or the immediate sequence of the signal will be fed as an input to this processor, and this processor will in turn take the analysis whether the signal has to be go in a further form of thing and kindly proceed with the advancement in the level of technology. So there are so many versions of the TMS 320 has been coming with consist of floating point and the multiprocessor digital signal processing, but all these are meant exclusively for one simple application, is nothing but real-time signal processing. And there are multi-processors are also have come. It is not done performing a standalone or a single processor. Multiple operations can be done at a time in order to perform or to sequence or go in line with this analysis. There are a series of digital signal processor platforms are coming to the picture, and there are fixed point devices or the floating point devices, and the version of C62 and the C64 are meant exclusively for the fixed point devices, and C7 series are meant for floating point devices, where in which floating point operations can able to take part in this series. And all the three velocities architecture, velocity architectures, high performance Verilog instructions word architecture, or the major and the challenging task where the TMS 326 series are being facing nowadays. Here the advanced features includes give a code size for 8 instructions. Okay, this is an 8-bit processor, and we try to reduce the code size, program fetching amount, fetching cycles, and then try to consume the power to what possible extent it can be able to do. And not only at the same time, it also reduces the cost which involves the branching of operations, and try to see whether there is a parallelism which takes place in the sequence of executing the instructions. Of course, they are fully pipelined with zero overhead branching. So when there is a pipelining is there must not be any kind of overlapping. This TMS 320 series of the DSP processor is being designated for such applications. Additional important features, if you see the architectural view of this particular diagram of this processor, the main important thing we can able to see is nothing but they will have a 6 arithmetic unit and 2 multipliers, and try to go up to the execution of 32-bit instructions per cycle, and they are highly developed for risk-based courses. fine. And here the CPU is also been made up of with a 32-bit general purpose registers. And there are variable width of instructions which are possible here, whether we can go for a 8 or a 16 or 32. It depends upon the proficiency of the user to be analysis of it, but it has an efficient memory capacity and memory support for doing or for analyzing this support. And we have an efficient code execution on the independent functional unit also. Code execution we have, and the time duration for the executing a particular instructions may not be more than a fraction, more than a seconds. It will be very few seconds. Bit manipulation, field manipulation, instruction set, bit counting, these are all the additional features which we can able to perform. Apart from that, the hardware supporting, if you go and see, they will able to support for 32-bit as well as the double precision with the 64. But in general, the multiplying unit will normally serve here is nothing better. Two multipliers with 32 cross 32 or with 64 cross 64 bit. So when we say what are the architecture point of view, what are the parameters or what are the units which are associated with here are nothing but program memory, varying size, the peripherals, the DMA controllers, power down logic, external memory interface, serial ports as well as a post. This is the complete view of an additional architectural view of this TMS LS C series of 6000 DSP processor. It has a memory. Separately we have a DMA controller. Separately we have a memory for addressing 32-bit of address. Additionally we have a port for the serial port communications for timing as well as the counting operations, for serial communication for transferring and receiving with our transmitter and receiver pins. And exclusively there is a path wherein the data can be diversified from one unit to the other unit, and there is a fetching unit will be there for fetching the code separately, fetching the address separately, and we have an emulation unit, and we do have a provision for the interrupts. If there is any additional interrupts have come, then the interrupts will switch over it and try to see whether the mapping is possible at every possible extent to overcome the situations. When we see the central processing unit, this unit is normally consisting of program fetch unit, where we need to fetch the instructions and try to see, generate the opcode and generate an object for creating a particular thing. Everything will be analyzed and viewed by this particular thing. And we do have an instruction dispatch unit, and we do have an instruction decode unit, and try to see all these things are at the multiple levels and multiple stage to overcome these sequences. And we do have 32-bit registers and test emulation and the control unit. When we go in line with the memory, we can see there are 32-bit addressable memories will be there, and we do have internal program memory with of 26 bits. And it has a provision for supporting SD RAM as well as SD RAM and SRAM. And direct memory access to a particular micro unit system is also possible in case of this particular controller. We do have an EDMA controller for programmable interfaces, and then we do have a power down logic for reducing all the kind of power consumption that exists in this particular form. CPU data path and the control, if you see components of the data path, if you see they have a functional units, memory unit, register separately, control unit separately, and the fetching, opcode, decode executions, everything will be done at the respective levels through which it can able to access through which it can able to access the parameters, and that will be the common path where the data can be transmitted. And we also should know that as we mentioned, there are two data paths are available, and what are the consisting amount of registers is possible for holding the register B and A. So it is a 16-bit so we have A0 to A16 for register A. Similarly for B register also we have a B0 to B16. We have a control registers, and you can see a buffer. We can see there is a multiplexer is there, which will try to see decode the inputs and try to generate a source, which in turn try to play a vital role in generate a particular logic. and this logic will decide by the user to generate a sequence of operation. It could be an arithmetical operation or a multiplication or a division, what kind of, or it could be multiply, add, accumulated. Any formation of any operations can be done only with the help of these two registers, and which are of 16-bit in nature independently. So further down we want to see the functional units. We do have a fixed point operations and we do have a floating point operations. Each of them will be of 32-bit in form, and these are all the functional unit operations thing. General purpose registers we have to see means it has only A register and B registers. Combinedly we do have a 32-bit registers. Other than that, we have a stack pointer registers, we have a control registers, all those things, and the quantities in which all together will come up to the 32 bits. And even set of registers and odd set of registers, likewise in we have in microprocessor and microcontroller, lower order and the higher order, everything. And if it is of register storage of 40-bit of long, then you could be able to adjust with the zero filled data. Otherwise you can totally ignore the formation of thing. Memory load paths, if you see, there are load LSB or MSB to where you want to load. All these things we can able to see to that. Either you can load the path from data to the data from memory to register, or vice versa is also possible. Or if you want to load within the instruction also, it is possible here. In order to store a particular thing, we can able to use the instruction st1 for register file A and st2 for the register file B. Address path, if we see, we have a DA1 and DA2 are connected to the D units in both data path unit. We have a two data path, A and well as B. So either way you can able to communicate it associated with the timers T1 and T2 respectively.